Great. Thanks very much for having me. We're privileged to be speaking with the group here today. Aiden, can you see my screen? I'm just doing a quick share here.
Yes, that's right. I can see your share.
Excellent. Okay, and I'll just go presentation mode, and I will.
That's perfect.
How are we looking? Excellent. So the topic here that we're going to discuss will be more on the visual as opposed to the geopositioning of data collection. And I think, what's really interesting in the market today is what's going on with 360 imagery, the accessibility to 360 cameras, the ease of use, the low capex. And so we're going to talk a little bit about how we're bringing 360 into the oil and gas industry in different applications and having some significant value, particular from the low time it takes to capture information and the relative low cost. By no means in this presentation do we feel this is a replacement for GPS, LiDAR, or other technologies, and actually our solution kind of brings those all together, whether we're bringing in terrestrial LiDAR, BIM, and others. So I just wanted to make mention of that. So what we're going to do is just do a quick introduction in terms of why digital twins, talk a little bit about digital silos and what we can do to kind of help resolve the issues between different people in organizations and access to information, looking at different tools. And then most of what we're going to talk about today is a case study with QI2 and how they have been using 360 and different elements of the tank integrity inspections process. So I don't need to introduce myself. Aiden did a great job. Thank you very much for that. So why digital twins? And from our perspective, and especially from a 360 perspective, what we're trying to reduce is the touch points to the facility, in particular site visits. In industries like oil and gas, safety training, getting access to areas, it's time consuming and costly, and there's travel. So whenever we can use a digital replica to be able to verify, validate information remotely, but accurately, we can see some time savings and cost savings there. Also, digital twins allow us this 24-hour access. And I think everyone in the room has been working with different types of geospatial data, so I don't need to talk too much about that with you. So I have, kind of a couple little quick video snippets of like some very large refineries where we can really drill in and pinpoint a particular area and have this virtual walkthrough kind of Google Street View ability to inspect and verify and validate information from an imagery perspective. We can then bring in your BIM, LiDAR, and other data sets to confirm the accuracy of that data. The key point here is that data collection done on a hard hat with a $1,000 camera with the general worker walking through the facility can capture, collect, and auto process this information into something meaningful to augment those other data sets. So that's kind of what we're working on. So a couple other environments, a pipe rack application, just trying to give you ideas here. So we have a Revit model on the right, we have the 360 on the left. And again, just be able to have the as-built as-is current conditions, especially when there's change. So there's obviously some significant changes on this particular project, where it's nice to be able to validate that without having to be in person. This particular project is electrical substation project. So put it in perspective, we captured in 8 business days, 25 electrical substations in the Midwest. And these were each about 100,000 square feet. So up to 4 substations per day, and literally have thousands of photographs that we can go through and then start to annotate and provide notes and to communicate with other stakeholders, subject matter experts that are involved with project work and whatnot, about how we're going to do something or where something is located. And that's critical for us to be able to do our jobs effectively. And then we're also using the technology in some limited fashion with doing asset tagging and bringing in this data into CAFM systems, facility management systems. Obviously, some limitations here where BIM is going to be a preferable option, and we do bring in BIM as well. So depending on how many asset properties and what level of details on the attributes of assets that you need to collect and organize, this may be an effective solution or may not be a fit, and BIM might be a better fit. Okay. So these are just some ideas on how you can leverage 360. We link photographs, we link other types of information, web pages, etc. So let's talk briefly about data silos. So there are a lot of different types of data collection that happen within the refinery process, oil and gas. You have drone data. We are putting 360 cameras on drones now, which gives us a really unique way to not only see a top-down view, but to be able to spin around, zoom in, and to be able to seamlessly navigate from one panel to the next to be able to get that kind of full immersive environment. There are some limitations on the resolution here, so augmenting that type of environment with some high resolution photographs is also something needed today. We do have a 200 megapixel 360 camera on this particular drone with our partner Precision Aerial out of Houston that does a ton of work in the oil and gas industry and work with us. Terrestrial LiDAR, again, I used to work with Faro, so a lot of work being done with terrestrial LiDAR, and it's invaluable to the process of scan to BIM and for verification, especially with deviations and floor flatness and all sorts of things. So that's never going to change, but the scalability of scanning huge infrastructures quickly to manage operational change may not be the right fit. So having a point cloud for a purpose of precision and then implementing 360 as a way to capture and monitor change over time from a visual perspective can be really helpful. And then the same goes with BIM. BIM is really valuable to have if it's used, but it is a costly process. So how can we augment the BIM process, both from a managing BIM and managing CAD process by having visual information that's current as-built information, or do we need a BIM of a particular location? Is a 360 going to be sufficient and valuable for us? And at the end of the day, what are we trying to do is take these different data sets into a single ecosystem, which we can compare them and validate information and navigate through them. And more importantly, to get our data in a digestible format that regular operators, maintenance teams, owners, the wider audience can use this data in a meaningful way. So, when it comes to managing the assets, we want to increase the amount of uptime, and mechanical availability is about a 10-fold return on investment to doing so. So I'm going to turn the conversation to Kevin Kupitz at QI2. Kevin has got a huge background in tank integrity inspection, pipeline inspection. He's been already introduced. I think you're going to really like what we've been doing in his process with tanks and applying a process of photography that takes maybe 90 minutes, 20 minutes to upload, and literally having same data, same day, where our oil and gas partners are starting to collaborate with people in the field, which is pretty cool. So Kevin, you're on.
Thank you, Kelly. Can you hear me?
Yes.
Okay, good. Appreciate that. And thanks, Kelly, and thanks, Aiden and the APSG for allowing me to present this above ground storage tank case study. And thanks for getting off that slide. Basically, it says that I'm old, right? So I appreciate that. Anyway, my background is 35 years or so in the oil and gas and power inspection industry, working with major oil companies on a daily basis. You can just imagine. I mean, I think we had a fellow on here earlier from BP, and so those are some of the customers that we cater to. So you can imagine they're pretty much high visibility, right? So one thing I did want to go over real quick is a storage tank, right? So storage tanks, many people think are basically a can. There's a lot more mechanical aspects to a storage tank. And you can understand how important it would be to get all the information we possibly can get. So what Kelly was showing before, with all the facility scans and the pipeline scans and the pumps and whatnot, we're just honing in here on a specific tank inspection scan. So not just identifying the location of the tank, but actually performing an inspection and using all the 360 3D LiDAR data to store in a what I would call a digitalized way. So there's no fooling ourselves. We have to start getting digitalized, right? So I'm going to give you a little background on tanks and what we do for tanks. By the way, these tanks, it doesn't say it on this slide here, but they're regulated, obviously. The EPA has their hands in it. The FEMSA has their hands in it, especially for DOT type tanks, fire marshals, the NFPA. So you can imagine there's a lot of people looking at these tanks. If a tank leaks, gets into the water, you know, that's the major reason the EPA is all over these tanks, right? So there's over 1 million ASTs in the United States alone. So when I say 1 million tanks, I'm talking about 1 million large tanks. So these large tanks would be considered 30-foot tanks diameter and over. You can add another couple million tanks for tanks that are less than 30 feet. Different standards apply to both the large and small tanks. But the 360 scans we're using them for both large and small. So also they must be externally, these tanks must be externally inspected every 5 years. So you can imagine every 5 years we have to put a report together, and we have to make sure that the tanks are in good service and that there's no, we're trying to predict, right? We're doing the reliability of these tanks, trying to predict that, there we go. I'm going to start my video up real quick. Trying to predict that these tanks are fit for service. So you can imagine how important these scans are. Of course, if we inspect a tank and the tank fails somehow, there's a large liability there. These tanks also have to be internally inspected. What I mean by that is these tanks have to be inspected while out of service, at least every 20 years. If we inspect a tank during the 20-year inspection and we decide that this tank isn't going to last for another 20 years, we have to give a new sequence on inspection. So maybe it comes out where it's only good for 5 or 10 years. So those are the sort of decisions we have to make when we're inspecting these tanks. Tanks that are in good shape and that have good containment and are taken care of very well can go over 20 years now. But so what has to be done for these tanks to be taken out of service? You know, they have to take them offline. There's an opportunity cost for that. They have to empty these tanks. They have to find another area, another tank to put them in, or temporary tanks that they have to put on site. They then have to clean it. You can imagine that a large, let's say a 200-foot diameter or 300-foot diameter tank that has a whole bunch of crude in it is not that easy to clean with all the sludge on the bottom. So that could take months to clean. Then we go in after it's cleaned and power washed or power blasted, grit blasted, we inspect the tank. And the inspection could take anywhere from 2 days to 2 weeks. Once the inspection's done, we supply all the recommendations for repair to our customer. The customer contacts the repair contractor, and the repair contractor then does all the repairs, hopefully the way that they're supposed to be done. There's obviously guidelines and standards for the types of repair. That's API 650 and 653. And then post-repair inspection. So we would go back out and make sure all the repairs were done, what repairs were completed, and that they were done in the proper manner. Then, of course, we're going to test and refill the tank. What's important to realize here is most of the tanks that we inspect don't have drawings. Matter of fact, many times the customer cannot even find the external inspection that was done 5 years ago. So what we're trying to do is make sure that these inspections are available and that we can use these previous inspections to predict future problems. Cost the industry average, by the way, to take a tank out of service can be anywhere from $500,000 to $2 million, depending on the service of the tank and what's and the condition of the tank, okay, and actually the location of the tank. So, and another standard or baseline would be for a tank to be out of service. It could be there's a large range here, but about $35,000 a day. The costs for having a tank out of service. So the current technology, it's important to go over this because the current technology is we would inspect the tank, and the tank would be, after the tank inspection is done, we would supply a report within anywhere from 2 to 14 days, depending on, again, the condition of the tank and some other findings that we might have and additional engineering, et cetera. There's the tank report is about 80 to 100 pages. It must be interpreted through pictures, charts, graphs, and drawings. We do give a detailed explanation of the conditions, Matter of fact, one thing that you can't tell that you can tell with 360, which I'll go over in a while, is just the general condition of a tank. You could imagine that when you say, hey, clean a tank, and the tank had 5 feet of sludge in it before, 1 foot of sludge looks pretty clean to an operator, right? Well, that's not what we need. We need to be able to find any small pinholes in that tank, you can imagine, and any small cracks, et cetera, and any maybe some mechanical damage, et cetera. So we also would have conversations with SMEs or stakeholders of that tank based on our description and maybe a picture being sent with a camera back and forth. Try to explain to make an accurate decision and a reliable repair plan is really hard when you're just trying to describe something. And then the pieces of the report are sent to the repair contractors, which are the pictures and the repair plan for them to send you or give you a quote. I mean, we're only catching information that's specific to that tank too. So what's kind of neat is many times after we perform an inspection, they'll have the company, the major oil company or the midstream company will invite, let's say, 7 bidders out to walk the site. You have 7 bidders, and let's say all of them bring 2 people, 2 representatives, you have 14 people on site. Anybody in the oil and gas business knows that safety is #1, right? Nobody wants anybody to get hurt. Nobody wants to increase the risk of any safety incidences. So keeping people off site is a big advantage and is very important to all power and gas and oil companies and petrochemical companies. So you're eliminating the chance of any safety incidents, first of all. Second of all, you're speeding up the process for being able to do a walk around. Instead of setting it up for 2 weeks from now, this video is readily available as soon as the inspectors leave site. So now the repair contractors can actually take a walk around the tank. This right here is just a video from one scan. It's just like a street view. You can walk all the way around the tank. You can go up the stairs to the roof of the tank. You can go through the manway inside the tank. So you can see every inch of this tank, the outside and inside. What's real important, I know for the repair side, is they can get to site after seeing this and know where they can stage their equipment, know where they have to put their, if they have a crane, and there's no surprises. So they get, let's say the company gets a price of $500,000 to repair the tank, and all of a sudden the repair crew shows up and they find out that they can only park their vehicles 50 yards away. That's going to cost more money. So there's your first surprise. So in our standard report, you get a picture such as on the left-hand side. It's a nice picture. It does what it's supposed to do, but you can see the difference between the 360 video and just a picture. The picture is supposed to show the weakest joint on the tank, which is the roof to shell joint. That's a frangible joint. We have to do an engineering and evaluation on that joint, but you can see here around, you can see the handrails, you can see the components that are around the tank, you can see the stairway. You can just basically see where it's located, the general direction, et cetera. So I think everybody can understand that's watching this presentation is there's so much more information to be gathered on the right-hand side with that video than the left-hand side. And the best part is it really, as Kelly mentioned before, it only takes maybe an hour on site or an hour and a half on site to capture this video. So the price is not is not consequential. So you have a low price for quite a bit more information. Kelly, thank you. So some of the advantages real quick. We're showing a picture here of the inside of this tank. Now the inside here that you see on the picture here on the left-hand side actually is the internals of the slide a couple of slides ago. We saw the pipe coming into the tank. But when we do a 360 scan, as I mentioned before, we're doing the shell, the roof, the bottom. You're also seeing the containment area, the piping, and all the other areas around the tank. Sometimes for a tank, we need to use a drone. As Kelly had mentioned before, we can attach these 360 cameras to a drone. And a lot of times the roof is not in good enough condition to even walk on. So a roof of a tank can be very, in that vapor space, can be very corroded and pitted. And sometimes those roofs are not necessarily made to walk on. And then you can view internal and external images together, which is quite an advantage. Remember, I said that tanks, you don't want to get in those tanks, before 20 years if you don't have to, because you're going to spend an extra $1 million just taking the tank out of service and cleaning it, inspecting it. you want to keep that tank in service and running as long as possible. So it's great to have a view of what is on the inside of the tank as it relates to the outside of the tank. Tanks, typically, the problems with tanks, besides leaking, you know, you don't have a whole lot of catastrophic failures with tanks. Get hit by lightning once in a while. You'll see a tank fire once in a while. But typically, it's tanks that are floating, tanks that have wind damage. They're gigantic sails, right? And typically, if the tank floats, you want to know internally where those pipes go, because now you have a lot of stress on every one of those pipes that just moved because the tank floated in 2 inches of water. One of the surprising aspects of using this 360 technology is the spatially located findings. Customers have really made it known to me that just basically seeing where the inspection findings or the problems are in relationship to other components is a huge deal. It's a huge deal because our codes require that we keep certain distances away from welds, et cetera, so that there's no cracking and no future damage. So that's what I meant by determine closest weld components. So just knowing where they are and what the access or the interference is to any of these locations are very important. And also, if we needed to, we could take measurements on the spot on the 360 scan, if there's any questions. So here we have some more advantages, location. So what I wanted to show here is that it's in what we call in-environment flagging. So typically what we would do on a normal report is we take a picture of, let's say, that box there with the X is an area that we say that there has to be a patch put there because it's a thinned area on the bottom side. We found that with some technology we use to scan a tank floor. So you can't see it there because the damage is on the underside of that floor. But we labeled it right there. And on that label, we tell them what they have to do, what the damage is, all the details, et cetera. So here we have, you see, not in the video, but below the video, that's nozzle U with a repad there and an annotation. Now, if you click on nozzle U, you can see nozzle U on the inside and where it's located and what else is around it. So again, spatially located. Again, with these annotations, we can say that these are recommended actions. In other words, that you have to repair them. It's per code. We can say it's a good engineering practice. Maybe that's yellow, and that's something that you can decide as a customer if you want to repair. It's just good engineering practice. And observations. This would be basically an observation. We have the U on the outside. It looks good. And now we're just showing you what it looks on the inside. You can add a voiceover video here if you would like to, a link, a note. I can add, and I have added excerpts from our report directly on all the thickness readings and all the measurements around nozzle U. So all you have to do is walk around this tank where there's a blue annotation, click on the blue annotation, and instead of paging through a report and trying to figure out where this is and how it relates, you have it right in front of you on this site. So some of the other items that have helped us quite a bit are just being able to share these scans with our engineers while the inspectors are on site. Instead of an inspector, again, trying to describe something to an engineer, we can actually, it's like he's there. Now we can make specific additions to the inspection scope if we need to do further evaluations. And also we can come up with resolutions to how we're going to go ahead and produce a repair for these areas. And then after the inspection, it is common now that we do a walkthrough with the customer. Many of our engineers for large customers are at a central location, let's say Houston or Findlay or Chicago or wherever they're at. And now they can actually be there to see all the inspection findings. And we can make resolutions. We can resolve the problems right there. So the construction or the repair can start almost immediately after. We're not waiting 10 days and then evaluating that report for another couple of days. This is being done right real time. And then the report, once the scan is done, it is automatically, it's posted, and then the repair contractors can take a look at it immediately and start buying materials if they need materials, or start sending or produce a quote. So there's so many advantages to this, and it's just, you can imagine just to be able to visually see this is incredible. We're talking about a confined space here too, by the way. So getting inside these tanks is not just walking in these tanks. It's sniffing the area. It's a confined space again. You know, we want to make sure the oxygen content, the LELs are good. But here's another thing. So on the left-hand side, let's say the right-hand side is our original scan. On the left-hand side is our post scan. So the left-hand side is the scan done after all the repairs were complete. So you can see one thing is that a aluminum floating roof was added to this tank between, I think the dates are on the bottom there, between February 3rd and March 28th or whatnot. And you can also see annotations in there. You can see the diffusers and where the product comes in and out. But you can see those marks on the floor. We can confirm right now that those marks on the floor have been patched. You can see there's a red mark there right below that nozzle or that manway. And you can see now that there's been a patch applied. So you can resolve that. Now, again, we want to produce, this is the last scan. So after we understand everything's done, now we have an actual as-built, a digital twin on the inside of that tank. I can tell you that most people have no idea what's on the inside of their tank until they take that out of service. Sometimes the tanks are taken out of service, changes are made. I think John might have said this in his previous slide that, you know, you need to make sure that all your drawings are updated. And here with a scan, you know what's inside that tank, which is very important, again, for many reasons. Is there a next slide? So basically in review, there's a couple items that you can do, and you can imagine the immediate savings for doing a 360 scan. By the way, how we got on the 360 scan is we still do 3D scans to do the plumbness, roundness, and predict the way the floating roofs are going to move up and down without getting hung up on the shell if there's a deflection, or if the tank is out of round or even tilting one way or the other. We got into 360 scans, and I've got a hold of Kelly because we used to do the 3D and then do photogrammetry after that. Well, this is a lot easier and a lot faster. We still do that, but this is a real quick and easy to get a good idea of what we're looking at. So we get in there and we do a pre-inspection scan. The repair contractors can look at that scan and give you a repair plan and give you a quote right away within a day. The repairs are performed maybe within a week, and then the post-inspection is done. Hopefully, you know, once everything's resolved in the post-inspection, we see everything's done. Now you have your as-built. And stage 6 is basically an ongoing scan of the terminal to look at coating, look at containment, et cetera, for EPA and PHMSA purposes. And that's it. That's a lot in a little amount of time. And I just want any questions?
Yes, we actually have a couple questions. So the first question, in terms of turnaround time, what's the average time savings you're seeing in lead times prior to the bid request?
Kevin, you want to take that?
Yeah, I can take that. So prior to the bid request, so once the project is awarded, we can easily take off 2 to 3 weeks. Basically, it's the amount of time it takes to make decisions and correct decisions. So not only does it reduce the time that the tank is out of service, which is measurable as far as the cost, it also gives you more accurate information. And now you have your SMEs from the major oil companies and our engineers deciding what to do and making accurate assessments of the failure so that the repair can be done. We may even condemn a tank based on these 360 scans.
Okay, thank you. Another question is do you see AI, machine learning, et cetera, taking over the personnel visually completing the inspection after a 360 model is created? So thinking along the lines of automated anomaly detection.
That's a real good question. So we have there's a lot of aspects to this, and this 360 is one aspect. You know, we're looking at ROVs to go inside tanks. We just digitized our whole inspection process, so it is totally digitalized, so it works with the Internet of Things, et cetera. Those are big acronyms that I don't quite understand, but all our developers are doing this, and we've given them direction to go this way. But I don't see this 360 scan changing anything as far as the inspectors that having to be on site and assessing failure mechanisms and knowing where else to look. It's still, even though the 360 scan gives a lot of information, I think that it's a lot better to have a person there. It would be nice, though, at some point in time to not have to put people into a confined space, and I think that's where we're going with this at some point in time.
I think, one my comment, maybe reducing the number of people and the frequency of the visits is definitely a benefit, and especially with other types of vendors involved with those projects. So definitely reducing those touch points. I think there is some opportunity to run AI on the pictures to be able to identify anomalies, things like this, to augment the process in the future. But I think we're a little ways off from that at this point.
Absolutely. We're getting there.
Thank you. Another question that has come in is, what other general oil and gas industry uses do you guys foresee in the future?
Well, I can tell you that we are doing facility scans for managing operational change. There's asset taking application, doing pipe racks, doing drone flights, especially for complex piping and other types of assets that are on the rooftop. So really anything that requires someone to go and physically see something as an inspection compliance or as a maintenance aspect, visualization plays a role. So every day we learn new things about how our clients kind of want to use visualization. Yeah.
I'd like to add that we use this for training also. So when we find unusual items, we have a recording of them, and when we train our inspectors, we can actually show them specifics, and we don't have to have them in the field for 3-4 weeks. We can go over tanks and show them what we found and how to inspect the tank too.
Yeah, I mean, the point here, we have a $1,000 camera on a tripod or a hard hat. That's your CapEx. It's almost zero. That's a key aspect. And then the competence to be able to do the camera, the photography can be done by operations. Again, it doesn't take away from your geospatial data collection. That's always going to remain. It augments it. It allows you more frequent visualization to be able to use and rely on the baseline of accurate measurements for those types of critical decisions.
I did want to add to that question before, is we still have to perform ultrasonic measurements. We still have to perform magnetic flux leakage. We still have to perform mag particle examinations and vacuum box examinations. So visual is just one part of the whole inspection.
Right. But thank you. I think we went slightly over. I appreciate the time and the questions. And feel free to get in touch with Kevin or myself if there's any questions or any projects you'd like to discuss. And we'd be happy to speak with anyone on the call today. And again, Aidan, thank you very much for allowing us to speak today.